welcome to the Astro Imaging Journey channel. Please enjoy the episode.
Hello and welcome back to my Astro Imaging Journey channel. And kind of interesting, different viewpoint today. Welcome to my office. Was blinking my data earlier and, had an imaging session last night and noticed something a little bit interesting, and I thought I'd share with you guys here real quick. I believe this is going to be episode 189. I've already got several episodes scheduled and uploaded, so I'm not sure when this one's going to actually go up. But regardless, what I wanted to show you here was asteroid, UFO, I don't know. So hopefully we'll be able to find out. And so what we have here on the screen is I've got two of my targets loaded up into Blink. You can see here we've got NGC 1555, Heinz Nebula. Doesn't look that great, it's pretty faint, but if we come down here, we've got NGC 2903, which is a nice galaxy. And what we're going to be looking at here is, in this one, I believe it's up here. So let's do a little play. You can see right here, we've got a nice little transiting object. I'm guessing asteroid. Not really a UFO, but right now, technically, it is a UFO to me because it's unidentified. So in NGC 155, it's up here. And when we get down to NGC 2903, we can see it right down in this area over here. So as you can see, it keeps flipping back. That's because we've got the different filters. So what I've gone ahead and done, let me close these out, is I've gone ahead and actually, this is in my original directory, and I'm going to need that for the data analysis. But I've gone ahead and copied them over to another directory and renamed them and took out the extra data, the camera gain, the filter used, just so I can get a better animation of what's going on. So I'm just going to go ahead and I'm going to select all and open them up into Blink. Goes pretty quick, so should be here, and there we go. And we'll make the image a little bit larger. Now, of course, these are all different filters: luminance, red, green, blue. So our background is going to change a little bit. So we just go ahead and we click the top one here, so each one gets stretched individually, as opposed to using the first image and then stretching the rest to match it. So let's wait for that to complete. Now that that's complete, let's go ahead and play our animation. Again, this one was up over here, and NGC 2903 was down here. So if we play this, there it is. Now we get a slower motion because each frame is now time-stamped and it's sorted by that timestamp. And then down here, we got it right down here. We're back up over here. Move my mouse out of the way in case it's missing a little bit or covering it. And then when we come down to this one, it's down here in this section. So I thought that was pretty interesting. Now, what I don't know is, what object is it? It's bright enough. It's probably a known asteroid. And I've never come across this in any of my data before, at least not that I've noticed. You know, as we progress and we get better, you know, we can start to notice these little nuances, these little transiting objects. Up to this point, I was mainly focused on, was my data good? Did I acquire the data properly? Did I have any satellite trails, airplane trails, meteorite trails, anything in the data that just I had to throw out? But now my data acquisition's gotten to a point where I have to worry less about the acquisition itself and mainly focus on what is different in the images and plane satellites. You know, they're that nice bright white streak that goes across, and they're easily picked up. So I make a cursory blink to make sure there's none of that in my images. And then I usually go back and I just do a quick little look, and just to see where I'm at. And in this particular case, I wouldn't see it in this. If I was shooting with a one-shot color, I wouldn't have noticed it because it's such a slow transition. But when we were looking at the other one where I still had the filter names and everything in the file name, it jumped, and then it jumped back to on the next filter, and it jumped because when I'm taking my data, I rotate through the events. So I do one image in red, then it moves to the green filter, then to the blue filter, then the luminance filter, then back up to the red filter. And so there's at least a 15 to 20 minute gap in between each red filter, each red filter's image. So, if it's transiting several pixels in each exposure, then 4 exposures later, it's jumped 3 to 4 times that distance. So it's easier to notice things like this when I'm looking at the per filter set, which we saw at the beginning. And then sometimes I would notice something, but it just didn't seem to, it didn't catch my eye like it did this morning. These were nice and bright, and now it kind of makes me want to go back to some of my older data and see what I got. But in this particular case, I had enough data for both of these targets to be able to see that with my own eyes just by looking at the blink tool. So now I need to figure out what these are, and that I'm not too sure on how to do. I believe there's a program called Astrometrica, which I'm going to go research right now, and I'm going to see if there's any other options. And if whichever one works, we'll be back here in a few seconds video time to see what we can find out. So see you in a few. Okay, so like I said, I did a quick Google search to see if there's anything else out there, and I didn't find anything, real quick search. I could have spent a lot longer than 5 minutes trying to find something, but Astrometrica stuck in my head. Dylan O'Donnell from Star Stuff did a recent video on it, and it was mentioned on the Astro Imaging channel in one of their live shows not too long ago as well. So it stuck in my head. That's what I wanted to check out. So what we have here is we've got the website astrometrica.at, and it looks like an older style early Windows, Windows 3.1.1 maybe, Windows 95-ish type display, but if it's usable, it doesn't have to be pretty. So what we got here, as you can see, I've already clicked on a few things. Downloads, I've already downloaded, as you can see here. Where's it at? It's shareware, and we can use it for 100 days for free. And if we like it, we can register to use it. And what's the registration? Registration is 25 euros, right there, 25 euros. So it's free right now. I'm going to check it out. If I like it, I'm a proponent that even if it's shareware, even if it's open source, there is a community, there is a developer. Contribute $5, $10, whatever you can, to help them continue developing it. The more funding they receive, the more time that they'll put into it. It's just human nature. If you're getting paid to do something that you normally are doing for free, you're going to be more likely to invest some extra time and extra effort into doing it. So I'm a big proponent that if I like something, even if it's open source or shareware, I'll contribute what I can to further the efforts. And in this particular case, we can use it for free for up to 100 days. That's great. And then after that, we'll have to pay for it if we want to. So yes, it's shareware for 100 days, but I think the wording on that should be a little bit different, but that's a conversation for a different day. So we go back to the download section, we come over here, we've got the installation package, and then 2 zip files. I've already downloaded the installation package and ran it, and you can also see, like I said, it looks a little antiquated. They go all the way back to DOS days. That's bringing back some memories. So we won't go there either. So let's look at, there we go. So as you can see, I've already installed it, I've launched it. We've got our nice little warning here, 100 days left for evaluation. And we'll click continue. I haven't done anything on this, so we're going into this blind. And like I said, this channel is all about me learning, me growing, and hopefully helping you guys out and doing some of the same stuff. If you're having troubles or experiencing some of the same problems I'm doing or I'm having, and in this particular case, I noticed, I got a transiting object. Is it an asteroid? Let's see. So we will expand that out, and this is where I'm going to be completely lost. We should have some tutorials. Let's look at, I don't see it was supposed to have it, but I click on help contents, there's nothing. Interesting. So let's go to settings, and I'm going to have to set up some of this information. I believe the MPC code, you have to submit data a certain number of times before you get issued an MPC code, but I'm not 100% positive on that. Lat and long, I'm going to have to get from my data and my height above sea level. So I'm going to fill in this information, And then we also have our imaging rig, what focal length are we running, what angle were these taken at. Let's see, it says CCD, but that's just, that can be one-shot color, CCD, CMOS, whatever the case may be for your rig. So I'll have to input that. And you can see we've got our color bands. So blue, red, Gaia broadband, infrared. So it looks like wish that help would have shown up. But that's okay. So I will definitely be submitting or looking at the red. So that's why I made two directories. The renamed one so I could do the animation, and then the originals, which keeps the filter name in there. Because I suspected, since it's not one-shot color, I would need to do a filter-based. So we've got red, blue. Visual, I'm going to assume is luminance. Time in the file header, that I'm not sure. End of exposure, I think it's end of exposure. So I'll have to edit that. And leave star catalog, we're going to want the Gaia DR2. Object detection, so I might have to play with some of these settings. We'll get into that. Okay. Catalogs, we'll leave these. And I'm not going to worry about filling those in right now. If I had an unknown object and I would be submitting data, I might want to update this, but right now those are bright enough. They're probably known objects. So let me get these filled in, and we'll be back here in a few minutes. Alright, so as you can see here, I've got my focal length in there. The position angle, I'll show you how to get that here in a second. And the pixel width, that's from our CCD. I had to go, and since I didn't remember it off the top of my head, I went over here and looked at this information right there. So we know we're 3.8 microns. Filter is red. I'm Eastern time zone. Exposure from fits. So here's a good thing to look at. So if we go to PixInsight, what I did was I opened up just one of the random images that I'm going to potentially be looking at. And you can see here is our exposure, and that's in seconds. So if we come back over here, we have exposure from the fits headers, and it's in seconds. Now, I'm not going to scroll up because it's going to have my location data, but in there is a whole slew of information. Let me see if I can scroll up. Okay, actually it was a scroll down, and you can see here there's my camera angle, which I've got the rotator. So that is really nice that I can, it's right there in the fits header. Otherwise, I would have to go into possibly SGP or something and place off the image to get the angle, but it's all right there, so that's good. So I was able to just round that up. You know, I could probably go ahead and be a little bit more granular and do 78.9, but it's going to do a plus or minus anyways. So we're good there. I think the rest of this I'm going to be okay, so we're just going to save it, click OK. And now I need to figure out what to do next, so I will be right back, because like I said, the help is just not popping up. I'm not sure what to do, so I'm going to have to go and look. So I'll be back in a few seconds. Okay, so the first thing we're going to want to do apparently is load the images. And again, I'm using the red filter. So let's go into good asteroids, originals, and let's go down to the red filter. And I'm going to open them all up. And there's our date and timestamp, which it pulls from the FITS header, so that's good. And get them all loaded up. Now that they're all loaded, let's look at blink images. Very similar to the not responding. It's probably just chugging along here. Now I use the default star detection settings, so I might have to make some tweaks to that. So when this comes back, I'll be back. Okay, so the blink has opened up, and as we can see it here, it's coming across right there. Flip the horizontal in the thing, that's perfectly fine, but we can see, or in the settings rather, we can see it transiting right there. So blink, it's blink module akin to what we have in PixInsight. So now I know where it's at. Right above. So I'm going to screenshot this. I'm just going to try to remember. So I got the 3 stars here. I got this little cup looking thing here. Little trapezoid. And it's going to be right above that. So I'm going to close. Let's see. Stop blinking. So if I come back over here, here's my little trapezoid with this one here. So it's going to be that guy right here. So let's see here. Windows. Let's tile the windows. There. Okay. Try to match. Yep. Okay. So I'll be able to have them right there. That's good. And actually, let me cascade them real quick. And the first thing, what are we going to do here? Alright, so let's look at astrometry, data reduction. And that was all, that's from the FITS headers. So we'll go ahead and click OK. Let's see if this is where the star detection settings might, like I was saying earlier, might need to be tweaked. So we will see what we come up with. Okay, so as we can see, only 3 were identified as reference stars. Okay. Let's try that. Yep, that didn't work. So I'm going to have to make some changes to my settings. So we'll be back here in a minute. Okay, so we're back and did some more research. Took a shower, changed my clothes, all that good stuff. And made some tweaks. So let me pull up the settings real quick. So you'll see I have my position angle. I got that from the FITS headers. So I made a few tweaks in here. I changed the star catalog to UCAC4, 10 to 25 on the magnitude. I'm just going to go to 5 on that. Image alignment's 20. And search radius 30. That's way up there. That's the maximum, I think. And linear fit, aperture, and I think that's all I changed. Let me save that. Now, one of the things it is doing a plate solve. So wanted to compare the coordinates, the RA and DEC, because I am running a dither. So each one of these is a little bit off from frame to frame. So in reality, I should register them, calibrate them, and align them, and then use those aligned images in this. I might have to do that, we'll see. But if we come up here to astrometry, or astrometry rather, data reduction, we look here at our RA and DEC, and there's 2 ways we can validate this, or if you didn't have it in the FITS headers, you could find it. The first way I did it was to go up here to nova.astrometry.net and upload the image. As you can see, this is the image we're working on right here. And right here is our RA and DEC. So if we move this off to the side, as you can see, we're pretty close. We're off by 10 seconds and about 33 seconds on that one. So I'll change this to 48. And this one to 25, round up. So that would be the first way of checking. But if you notice, it doesn't give us, at least I'm not seeing an angle or a rotation angle, which is fine. That would have been in the settings. And the other way is if you're using Sequence Generator Pro. So you can load the image in here and then right click on it, plate solve, blind plate solve, it'll take you to astrometry.net, and it gives you the same information here, but in this particular case, it gives you the angle, and the angle we have here pretty much matches what I already have configured. So that's another way to do it. So let's go ahead and let this run, and we'll be back when this completes. Okay, that has completed. However, I know from previous iterations this is not right. For some reason, it's hiding the error message, and we can see it detected 238. Only 5 are identified as reference stars. So at this point, I'm going to have to do a manual reference. So let's go ahead and do an OK. And I wish I could expand that out, but you can see we're almost on top of some of these, so maybe it just seems like something's just a touch off. I want to reduce. There we go. Now that's interesting. Look at we're off a little bit here where we're on the outside this way, on the outside this way, but we're almost right on in the middle. Let me decrease the focal length. That's moving us in pretty good. And if I increase the angle, all right, so 1925 gets us almost there. Still a little bit off on the edges, so let's go up a little bit. $1928 at 79. Interesting. Okay, so 1928, we'll change this. 1928 and 179. I've already got it here. I'm just going to go ahead and redo this. And I know this was 48 and 25. No. 48, 25, yes. So that was 50 actually, or 49, but we'll leave it there. Okay, so now that I was able to get that corrected, and then, you know, it kind of threw me while I was processing It kind of made sense. My focal length of the OTA is 1960, but I do have, we have the focusing, and the primary focusing mirror moves in and out. That might have a couple millimeters of travel, and the autofocuser, the moonlight autofocuser, moves in and out. And that's got to travel 3/4 of an inch. So that 1960 is not 100% rock solid, and that's not something that I thought of until I saw this. That the actual focal length, the true focal length, is a little bit off. So that was good to know. Good piece of knowledge to pick up there. And as you can see, now that I inputted that information correctly into my settings, no errors this time. It came up. I've got a lot of green stars, circles around stars. Those are my reference stars. The blue are the detected stars. So that was pretty darn good now that that's there. Racking my brain, and all it was one little setting. So we close that out. Now let's go up here. Let's blink the images. Just want to double check where that was, and it's right here. So there's our trapezoid with the finger, and it's coming across right here. Excellent. So we had, let's blink that again. We've got our nebula here, double star here, and just to the upper left is our trapezoid and finger, and coming across. There's our double, our trapezoid, our finger, and right there is our moving object. Now to see if this is a known object, we're going to come up here to Tools, Known Object Overlay. Alright, that is completed, and looks like there's a lot of known objects out there, but none right on top of it. But we'll see if one of these other ones will match it. So we'll come back up here, we'll go to blink again. And chances are it's this one right here. This one's a magnitude 20.2, and this one's a magnitude 21. This was a magnitude 15.8. The other two are probably just a touch too faint. And our time could be off as well, because I'm not synced with an NTP server. So I'm willing to bet it's this one right here. So we'll stop the blink. That is 0220. So let's see if we can look that one up. So what we're going to look at is we're going to try to, let's go to the first one here, and let's try to select it. Centroid. pretty good. We'll do OK. And we'll accept. Why not? And there it is. Selected it. That's the one I believe it is. So we'll do an OK. We'll accept. I'm just going to step through each one. And I'm going to make fine-tune adjustments. Guess I should have copied and pasted. But that looks right. We'll just copy that and we'll accept. Do that again. That one looks pretty good. Paste. Accept. Alright, now we're back to our original. So now let's look at the report file. So it's got all your user information up here. But I'm going to have that blurred out because, you know, internet being the internet. But here's all of our data. We can copy this first one here. Let's go ahead and copy that. Now let's go over to the MPC website. So here I went to minorplanetcenter.net, went down to observers, other observer services, and MP checker. That gets me to this page here. So I'm going to take that observation line that we copied. What we're going to plug in here is the date is 2020, 11, and we're going to copy this part. Okay, so it only wanted 2 decimal places, that's fine. Then we're going to take our RA, I'll paste that in there, and we're going to take the declination, including the plus sign, plug that in there, and we'll leave the rest of these default, and we'll say produce list. It should come up with a list here. This was within 5 arc minutes. Might have to up that one, but we should be pretty right on. And could have been either one of these two, I guess. But based on the magnitude, so if we go back over here, my magnitudes are around to 16, based off of what the software has detected. Come back over here, based on a 16, that would be our asteroid, minor planet, whatever you want to call it. 2,220, aka Higgs, and no extra data needed at this time. So if this had been, say, so if you look at this one here, they're looking for data between November 21st and December 21st of this year. So based on today of this recording, that is 2 more days. If I really wanted to contribute to the data, and I might have some dead time. I got a couple targets that are completing in the next couple days, and you know, I could take this information right here and create a target set and get more data. Basically use the luminance data or use the luminance filter. If the moon's not unfavorable, it should still be under 30%. Or I could use red or the blue channel, either way. And then I could collect data, and let's go back to this. So this already puts it into the format for NPC in the form they desire. Now, somewhere on here, I read that they're going to want more data than what is here the first time you submit. So, in theory, let's see, 21st, today's 19th, so Thursday, Friday, Saturday night, and nope, Saturday night's supposed to be cloudy. But let's assume it was a clear night. It's going to be a clear night Saturday night. I can do this target, capture some data, put this data set together. Up here, they're going to want some extra comments in regards to myself, my equipment, different things. Again, that information is on the website here. I'm not exactly sure where right now. And then I can take this file and email it to them. And we are now using our amateur equipment in citizen science capability to help them better predict orbits, size, magnitude, different things, and which ultimately leads to better predictions and just better data overall for not just these objects, but other objects that they might find in the future. So this would, there's a couple right in here that's pretty close that we could actually get some data on if I could see magnitude 21s, and that's the thing. If I might revisit this might be another episode and another for another day. I'm gonna play around with it tonight, I think. Flat starts, so register or calibrate my images, align my images, and see if that improves my detectability. Would I be able to see down to a 21? Or would I need higher gain? I don't know. But right now, I don't think I can see magnitude 21. Or at least I'm not seeing it in the data. Just looking at the images. But let's go back over. Let's look at the other target I had and see what we got there. Okay, so I'm going to leave my settings. So I'm going to leave my settings alone. Should not have to tweak anything, except for maybe which filter I'm going to use. Let me look at. So this was on this galaxy blue, red. I only got 2 red and 2 luminance. All right, we'll use the red. That's a shame I didn't have more on that one, but that's okay. I had a limited amount of time on that target last night. So we'll leave everything alone. We'll go ahead and load our images. Red. Yes. Yes. Cascade that. Actually, in this case, we can tile them. And let's go ahead and do our data reduction. And I'm going to want to double check these coordinates. So let's go ahead and close out of this. We'll use Sequence Generator Pro, open image. And like I said before, once we have it open, we can right click, plate solve, and we will do a blind solve. Okay, so that took a little over 6 minutes, 6.5 minutes, but we will plug that in. So we're 9:32:19, 9:32:08, and declination 21:31:24, 21:30:35. 30, 35. We'll go OK. All right, so we're going to have to do another manual. It's okay. We'll reduce our magnitude. And our position angle. What's our position angle? 77.03. Forgot about that. 77. Gets us pretty close. We can that should do us. There we go. We're good. So we'll pop that over. Now let's do a known image overlay. I know we're going to be off. There's a lot in the image as well. But let's go ahead and blink it. I'm trying to remember where it was at. Can't remember. Oh, there it is. It's one of these two here. Probably that one right there. So let's stop. Which one? That was my first one. So probably this 01343 at a 16 magnitude. So let's go ahead and add this one. Search for it. 01343, Nicole. Go ahead and we'll add that one. Accept. Step forward. Right there it is. We'll add this one again. I should have copied and pasted, but that's okay. And let's look at the data again. There we have it right there at the top. We'll copy this. And this time we'll put it in here. We'll just go ahead and this will be 1955. RA. Deck. Produce list. All right, so here's another one. Nicole, like I said, magnitude 16. If we go back to our data, we're close to a 16. So it's probably Nicole. No new data needed at this time. And oh well, tonight, if I had some space, or some time left, I could image tonight and tomorrow night. But like I said, I've got a couple targets I need to finish up, and this is one of those targets actually. So we'll have to see, but I want to see if I can get some data and put in a report for this one of these two, but magnitude 22 and 23, I just don't see if I'm going to be able to see them. If we go back over here, so we got, let's close out a blink right over here. Oops, oh, don't want to do that. I'm not sure why YK. I'm not seeing a YK. It's not in here. No, I'm not seeing it in here. And what was the other one? So that was YK212 EP189. It's probably hard to see in the compressed video on YouTube. But it does have the names underneath. I'm just not seeing a YK or a UB. But they're in that area within 5 arc minutes. So they would be in this general area, maybe just not on the sensor. But they do need data for these two. But I will have to look at, what did I say? Oh, okay. I will have to look at my data because some of these are pretty faint. 22, 20. Let's see if I can zoom. I don't want to click. this one here, where was that at? Like this is what we were looking at, which said it was about here. So it's possible that somewhere right in here was the other asteroid. Maybe I would be able to see. Just don't know. It's going to be really tough. Really tough. Just don't think I'm going to see a magnitude 20 in my data without going back. And like I said, I want to go back tonight or tomorrow. I'm going to do calibration, alignment, and see. It might show up in the luminance. Might look at that too. I'll do a follow-up video to this one to see if I can see any of these fainter ones in there. And if I can get down to a magnitude 20 or 22, then maybe I'll be able to collect some data on some of these other asteroids that they're looking for data on. So, but tonight, first thing I'm going to do, I'm going to make a slideshow because we got to share it on social media, right? So I'll make a slideshow that I'll put somewhere right about now, showing both of these targets and the asteroids that I'll then show, share on Facebook and whatever. But yeah, interesting little experiment. And first time that I've noticed an asteroid in my data, and yeah, just had to see if I could figure out what they were. Were they known objects, which, being that bright, and I'm seeing them, so somebody else should have seen them by now. But if they hadn't, then we'd be able to submit our data to the Minor Planet Center, and who knows? So maybe one of these days we'll actually have something to report. But for now, citizen science at its best, I think. So if you're out there running your rig and you just happen to notice something, by all means, check it out. See if it's something known, and you can always submit it. I could submit this data if I wanted to. They don't need the data, clearly, but if I could still submit it. But take your data, submit it. If it's unknown, or even if it's known and it happens to be data that they want, then by all means, do it. For many of us, this is a hobby. This is something that we, hopefully enjoy doing, and I know I enjoy doing it. We like making our pretty pictures. We like sharing things, printing them out, hanging them on the wall, doing whatever, making backgrounds for our PCs, or our desktops rather, showing them to our family and friends. But it just goes to show rather, that we can engage in citizen science on occasion using our amateur equipment, our amateur abilities, and further the knowledge for those that, at least as compared to me, much smarter, much more dedicated, and a heck of a lot more focused on what makes our universe tick. So, yep, I'm going to close out this video right here. It's probably going to be a long one. Hopefully you're stuck around this long. If so, thank you so much. I want to say, I hope everybody's staying safe and healthy out there. Please do your part. I know we're trying to do our part to get through all this mess. And thanks again for watching. Thanks again for subscribing. Please stick around for the outro. As always, clear skies. Have a good one.
Thank you for watching yet another video from the Astrometrica channel. Really appreciate your viewership. In our upper right, we have the latest video we've uploaded. In our lower right, we have what YouTube might think you would enjoy. And in the lower left is our subscription button. Please like this video, subscribe if you so choose. As always, clear skies, have a good one, and remember Duke.